I'm doing the last one on the back of the orange sheet in the bottom section, Fnet. A man holds a barbell still above his head. It has a mass of 100 kilograms. What force does each arm put on the barbell? And we're going to assume that it's evenly distributed. Evenly distributed across the arms. So if I have a free body diagram, I have the weight of the bar is pulling down. Always got the weight pulling down. This is a vertical problem. And then I have the guy holding it up here with his arms. So I'm going to call this force of the arm 1 and force of arm 2. Remember, it doesn't matter what you call them as long as you don't use friction, weight, or normal force. I also know that the mass is 100 kilograms. Because this is a vertical problem, I need to know the weight. And again, a little side bit here. Using the equation FW equals mg, you're either multiplying or dividing by 9.8. And remember, weight will always be a bigger number because it's a bigger word. So 100 times 9.8 gives me 980 newtons. So this here is 980. Alright, in part A, it's really important. It says that he is holding it still. So if I am not changing, so in part A, not changing means my acceleration is 0. And that means that the sum of the forces will equal 0. There's no Fnet, which means the ups will equal the downs. Right? So in part A, so I sum the forces equals m times A. I have FA1 up, FA2 up, and minus the weight down equals MA. In this case, I just have 3 forces. So I write them all down. Don't forget your negative for weight. And fill in what I know here. I've got FA1 plus FA2 minus 980 is equal to the mass, which is 100, times 0. This whole side will go to 0 because it's in equilibrium. So I get A1 plus A2 is going to equal the 980. Remember, that's the weight. So see how my ups added together will equal my downs? And as long as we assume that these are the same, I can say 2, the force of the arm is equal to 980. And so the force in each of the arm is 980 divided by 2, 490. See how if I drew that back on my free body diagram, I have 980 down and 490 up on both sides. The sum of the forces equals 0. This is no net force, which means no acceleration. So that's an equilibrium. See how I have ups equal down? In the second part, so this is part A. In part B, so I still have the weight and FA. I'm going to just call them FA because they're the same. And I'm just copying from above. Remember, the mass is still 100 kilograms and the weight is still 980 newtons. So that was just from the top part. KG. Except this time, in part B, instead of being at rest, there is acceleration. The acceleration is positive 4. So we're going to do all the same steps, but instead of them balancing out, they won't balance. Sum the forces equals m times a. I have FA plus FA, both up minus the weight down, equals m times a. So in this time, instead of having this half be 0, I'm actually going to have a number there. So I have 2FA minus 980 is equal to the mass times the acceleration. Still 980, and if I want to accelerate it up, these two forces added together are going to have to be greater than the 980 down, so I get a net force that's in the up direction. Solving 400 plus the 980, so 2FA is equal to 1380 divided by 2, and this time FA is equal to 690. Alright, so just filling this back in, if this is 690 on this side and this is 690 on this side, the ups end up being 1380, the down is 980, and that's how you get your net force of 100. Of 400.